Okay, so finally, the last part of this section talks about the very last form of the of a quadratic function, a quadratic equation. And this is written in intercept form. And what we can see from the intercept form is we can find the x-intercepts, we can find the axis of symmetry, it's even different than the other two, and we can know if the parabola opens up or down. Again, that's whether this thing is positive or negative. Okay, so this is a little complicated, this is in your book, but this is what I wanted to point out. So, the x-intercepts are P and Q, okay? Because if I put P in here, P minus P is 0, makes the whole thing 0. So that's one of the places where it crosses the x-axis. And the other place it crosses the x-axis is at Q, all right? So these P and Q are my intercepts of the x-axis. Now, if those two intersect in the x-axis, the axis of symmetry is going to be smack in the middle of the two. And that's where this comes in right here. P plus Q divided by 2. I don't want you to get hung up on these formulas and these things, okay? I just want you to remember you've got P and Q, axis of symmetry is right in the middle. Even if you need to graph it and point and count, it's right in the middle, okay? All right, so let's look at an example. Again, that's going to be the easiest thing. So it says, okay, label the x-intercepts, vertex, and axis of symmetry when we graph it. So, okay, so first of all, I notice that it's going to open down. This is negative, it's frowning. It's going to open down. One of my x-intercepts, remember I'm looking at, this is x minus p, x minus q, so I can rewrite this as x minus a negative 3, and then x minus 1. So one of my x-intercepts is negative 3, 1, 2, 3, and the other one is 1. I hope that makes sense. And if I want to find what's exactly in the middle, I can just look at the graph if I really want to. It's right there. Okay? But I can also take the average of the two. So if I add those together, negative 3 plus 1 over 2, that gives me negative 1. So here is my axis of symmetry. Okay? X equals negative 1. And then, like every other thing that we do, we take our axis of symmetry and we plug it into the equation to get our y value for the vertex. So negative 2 times negative 1 plus 3 times negative 1 minus 1. Negative 2 times 2 times negative 2, this gives me 8. So my vertex is negative 1, 8. So negative 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and when I have all of these points, these 3 points, then it's usually pretty simple to graph it. Okay, so here's my vertex, it's negative 1, 8. One of my x-intercepts is negative 3, 0, and another one is 1, 0. Okay, so now I want you to try this one. So go ahead and pause. All right. So this one we can see opens down. Again, it's negative. And our x-intercepts are going to be negative 1 and negative 5. Okay, so negative 5, 0, negative 1, 0. Right in the middle of that is negative 3, so that's my axis of symmetry right there. So my axis of symmetry is x equals -3. And now I plug -3 back in here. -3 plus 1, -3 plus 5. This is going to give me a negative times -2 times 2. So I get 4. So my vertex is -3, 4. 1, 2, 3, whoops, 1, 2, 3, 4. So -3, 4, x equals -3 is my axis of symmetry. All right, so finally, okay, there's been some confusion. I give you the assignment so that you can see what it is in your book. So if by some chance you can't log into Big Ideas, you've got the assignment. But this isn't 2 assignments here. This assignment right here is what you do in Big Ideas. So if you were to open your book and follow along, you'll see that this is in Big Ideas. This is a woodland jumping mouse. And one of your problems here, I think it's number 77, is about the woodland jumping mouse. And sometimes I can't think of pictures to put on here. So here's a picture of a mouse just for you goes along with the story problem. So good luck. Let me know if you have any questions.